Right, so nice to meet you, everyone. This is Davis Kim from AV News, and today we are going to have a meetup between Geekspin and CIT. And so we have Ms. Anna Trandafir from Geekspin, and we have Mr. Jung Sung, CEO of CIT, and Ms. Jungin Kim. What's your position? What's your
I'm researcher of
researcher?
CIT.
Nice to meet you. So, as we have all gathered here at this time, so at first we are going to proceed with the company's introduction, then move on to the product presentation. Then after that, we are going to do a Q&A session between Geekspin and CIT. So, so if everyone's ready, please proceed with your session. Thank you.
Okay, so good afternoon. I am Shannon from CIT, and here we are making waves as a copper material trailblazer for optimized data transmission. And allow me to explain why. To match the need for high-capacity data transmission, semiconductor industries are shifting from organic substrate packaging to glass substrate ones. Amidst this shift, there are many different technologies emerging to cater to it, and as a first mover with a breakthrough technology, IT material, and strong growth positioning, CIT is a front-runner commanding investor attention in this field. CIT offers deposition equipment, single crystal targets, copper deposition films, and license fees for ASE. The advanced packaging substrate companies are hence our main target market. As these industries' growth accelerate, there is an ever-growing demand for real-time, high-capacity data transmission and processing. This is becoming increasingly energy-intensive, and current materials like organic substrates are ill-equipped to keep up. Our solution to that is to offer ultra-thin, ultra-flat copper deposition technology with atomic sputtering epitaxy. So how does ASE differentiate from other competitors? Our strength is that ASE enables fabrication of ultra-flat, ultra-thin surfaces and environmental sustainability in production and process simplification. So this means lower data loss and faster transmission. Besides the metallization equipment for glass substrate deposition for semiconductor packaging, we can also produce FCCL and EMI shields, making ASE applications versatile, and any end consumer in the semiconductor packaging industry is also within our total addressable market scope. Here's an overview of our business model, and our cutting-edge copper IT material can create strong synergy with partners, driving mutual growth and strengthening advanced semiconductor packaging industry leaders. This is our playbook for scaling up with rapid growth forecasted, and we are also on track to hit our milestones for 2025. These are our current partners, product collaborations, and accolades. We received the Gadgety Best of CES and Best of MWC 2025 awards, CES Innovation Honorary Recognition. It is clear how much the industry and media have spotlighted our company, and we leverage this recognition to gain exposure to a wide market. We also built strategic partnerships from Harvard University and Massachusetts Institute of Technology to leading Asian tech giants in the advanced semiconductor packaging industry. We have successfully registered our patent for our original technology, ASE, and are in the process of extending it to ASE applications as well. So this is our revenue and profit projection. And following up, let me introduce our product in focus. Introducing Copper Flat Package Core, which is CIT's response to current industry advancements. As AI services evolve to require faster, copious amounts of data processing, traditional FR4 substrates are reaching their physical and thermal stability limitations to cope with this. The ever-growing need for high-density semiconductor packaging and energy-efficient systems has opened doors for the emergence of a new alternative, glass substrates with ultra-flat copper layers. So CIT has developed Copper Flat Package Core, a next-generation copper deposited glass substrate designed specifically for AI accelerators. This substrate not only meets the demands of speed and stability, but also overcomes the limitations of conventional plating methods. In a process validated by Nature and other leading journals in breakthrough single metal deposition, copper flat package core delivers unprecedented performance in semiconductor packaging. It enables surface roughness of less than 4 nanometers, high aspect ratio capability with uniform deposition in holes of up to more than 8:1 aspect ratio, and oxidation resistance maintaining stability up to 482 degrees Fahrenheit, more than doubling the thermal stability of the conventional copper. This innovation allows AI accelerators to maintain optimal performance even under thermal stress, thereby reducing energy consumption in internet data center cooling systems. Copper flat package core is also compatible with all major glass substrates currently used or under development in semiconductor packaging, like borosilicate and alkali-free glass types. It is also suitable for both interposer and core substrates. It enables high design flexibility for package engineers and uniform ultra-flat circuit formation even on high aspect ratio glass boards. Copper flat package core simplifies manufacturing by replacing complex multi-step wet processes with just a dry sputtering only approach. So ASE's process, although simplified, still delivers 7% lower sheet resistance than conventional copper layers, full functionality with 100% copper since a seed layer is not required, breakthrough levels of copper smoothness, and high data and transmission integrity. This challenges long-held assumptions about copper's limitations in substrates. Our product also exemplifies sustainable innovation. By eliminating wet chemical processes, there's no chemical wastewater produced. It also uses 100% recycled copper scraps, and carbon footprint is reduced by over 95% from 3.75 tons to 0.00175 tons per unit. So copper flat package core proves that high-performing technology can also be environmentally responsible. And let me reiterate our product's applications and future outlook. It is positioned as the core structure foundation for next-generation AI packaging applicable across AI accelerators and HPC systems, interposer boards in advanced semiconductor packages, core substrates requiring ultra-flat metallization, sustainable electronics in large-scale internet data centers. So CIT also aims to expand the copper flat series across multiple high-demand areas in computational and communication infrastructure. With that, I've come to the end of introducing my company and the product. We envision CIT to be the mainstream copper material used in the tech and advanced IT materials industry, and we will continue trailblazing beyond the limits of copper with our technology. Thank you.
Okay, well, thank you so much. It is really good to see you all again. I think we interviewed your company last year. We wrote about the small antenna, right? Okay, great. So this is all very impressive. I'm just gonna ask like a few questions that I think you already addressed in your presentation, but maybe you can go a bit more into it. Can you tell me a bit more about like the demand, the inspiration for this product? Like, does it come from a previous research area of your company, or how did you end up with this revolutionizing, I guess, the way the data centers are going to work?
So for that, I think with the emergence of AI, IoT, and HPC in the recent era, so there are many data usage and high need for high capacity data transmission. And so current substrate materials like the FR4 that we mentioned previously in our slides, it has less thermal stability and it's not as efficient as glass substrates. So that is where we came up with our copper deposition, and it is used for the glass substrate to transmit faster in that sense. So to your question where it's like how did we come up with this product in the first place, right? We wanted it to be something that copes with current demands of high capacity data transmission without compromising on environmental sustainability. So we are thinking how we can do that because we already offer our deposition technology and we just have to develop something that can cope with today's semiconductor industry demands because it's only ever growing, right? Like the AI and all the internet data centers are now under intense scrutiny for how much water and cooling they are needed to consume energy, etc. So that is why we developed copper flat package core.
Okay, so you saw an urgent need and you decided to address
Yeah.
it. Actually, can you tell me, unless it's too sciencey, but can you tell me more about this oxidation? I saw that it's oxidation resistance, and I know it's a big deal with copper. I mean, I know copper always oxidizes, right? So, can you tell me a bit more about that?
Let me
If
Can you show me another presentation?
Or she will show you another presentation. Yeah.
This.
oh,
Oh,
okay, great, thank you.
Yeah, so for this, the oxidation part, we have high heat resistance in the copper that CIT deposits, so it will withstand high temperatures and maintain stable performance in AI accelerators. At the oxidation point, ours is at 482 degrees Fahrenheit versus the normal 212 degrees Fahrenheit. So this prevents oxidation that you were curious about, and it extends the lifespan of the glass substrates that we deposit on. So this reduces temperatures in data centers and reduce overall energy consumption if we were to change to hourglass substrate. Yeah.
Okay, thank you. Okay, maybe I guess a couple more questions about your market. I think you've already addressed maybe some of it, but you're already working with some companies. I think you showed LG on
Oh, yes.
your slide, and I guess who is the going forward? Who are the first target customers for this product? And I know eventually you're aiming to put them into everything that uses AI, but in the short term, yeah. Is it for the U.S. market, for the Korean market? Is it going to be like B2B more? Yeah.
I answer from here. Our business model is B2B. We working with our customer company, and in this time we working with the Korean who makes AI accelerator board. So we through our customer, we working together for Microsoft who makes AI accelerator and next generation NVIDIA and several company of who makes PCB. About this glass substrate for the semiconductor packaging, we working with several American company who makes semiconductor equipment, but I'm so sorry, we have a very strong NDA with the American companies, so we can tell you name. But off the record, I can tell you we working with Lam Research, like Lam Research, who top three of the semiconductor equipment company like that.
Off the record, I will just say that you're working with some American. If I address this, just working with some American
Mhm.
semiconductor producers. Okay, thank you.
We in this time contact with AMET, Applied Material,
Okay.
who makes semiconductor equipment, and like LAM research, we have already NDA and we have a co-working with the American company. But as you know, this big company asked to us very strong NDA, so
No
we
problem.
can announce
We're not going
that.
to mention any names. Okay, thank you. That's it's really interesting though that you're able to.
And we working
Yeah.
with MIT and Harvard University.
Okay.
We have a co-research with the American University.
Okay. Can I mention that you're working with some top universities for research? I mean,
Mm, I'm so sorry, I don't understand exactly.
oh,
You
sorry.
can
Could I?
repeat the question?
Yes, for sure. Can I mention MIT and Harvard by name, or is that also off the record?
Oh, it's possible.
It's possible. Okay.
University can be possible, but company names is not
No company.
possible.
Okay, great. Okay, and I guess last question. Can you just give me some insight into what kind of medical products? How do you think this is going to help in the medical industry?
Medical industry, we in this time working with Harvard University, but I think we need a time more 2 or 3 years. We
Okay,
have some sensor for the medical equipment, but we just researching. So we had
okay,
some exactly graduate. We need more times.
okay, I understand. Okay, well, super interesting. I don't have any more questions. Do you have anything else to add, or do you have any questions?
Mm, I don't have a question to you, but we have some result. For example, oxidation temperature. We already uh, verify. We have a scientific thesis from advanced material and nano nature communications. So this technology, not only we, our work, we verify with the global scientific journal. So you
Nice.
can believe us.
No, no, congratulations. I saw that you were mentioned in Nature, so that's awesome. Okay, thanks a lot. Keep up the good work. And yeah, I don't have any more questions.
Oh yes, thank you very much for your time.
Yes, thank you for your time. DK, do
Bye.
you? Thanks.
Okay. So that will conclude the today's meetup, I think. So everyone's have completed your questions and answers. Okay. All right. So thank you for Mr. Zhang and Miss Trandafir for being part of this meetup, and I hope to see you at CES 2026 and good luck at next year. Thank you so
Yeah.
much.
See you next CES. Bye
Have a good
bye.
day.
Have a good day. Bye.
Bye.
Have a good day. Thank you.
Thank you.